Hey everyone, thanks for watching How To Pixel, and today we're talking all about DMX moving headlights. So this video is going to show you how to use DMX moving heads or anything DMX related in an amateur light show. One you've probably built using xLights and programmed with xLights. Originally, all the information in this tutorial was going to be packed into one video, but after seeing the length of it, I decided to split it up a little bit. So in this first part, we're going to talk about what is DMX, how is it different and similar to pixel data, and how can we incorporate it into our light shows. And then we're also going to look at the basics of DMX moving heads. How do they function? How do you get power to them and the data to them? And how do you hook them up to a controller? Do we need new controllers, or can we use them with our light show controllers we already have? All of those questions are going to be answered in this part. And then in the second part, we're going to talk about the software end of DMX and DMX moving heads. How we get it in xLights, how we set up these moving heads in the layout, how we program them, and how we get our controllers to talk to the moving heads. But all of that is going to be in this second part. For right now, you can use the timestamps in the scrub bar and in the description below to skip to whatever part of the video you want to see right now, or you can watch it all through, and then afterwards we'll move on to the second part in the next video. But for now, we're just going to get right into it and talk about what is DMX. DMX, which stands for Digital Multiplex, is a universal protocol used for controlling special effect devices. These can include lasers, fog machines, lights, but most importantly, moving headlights. If you've built an amateur light show before, whether with AC lights or especially with pixel lights, you'll probably understand DMX very easily and quickly, because it's almost the same as that. The reason why is because DMX uses channels and universes, and a lot of you are probably already familiar with what those are. A DMX channel controls a single aspect or a single parameter of a special effect device. Let's say if it's a moving head, that one channel could control the brightness of the LED, or it could control how much it should rotate, or what color the light should be. The channel can be set to a value between 0 and 255 to change what the parameter does. So if it's affecting the brightness of a light, 0 could mean the light's completely off, but putting it up to 255 could put the light at maximum brightness. You could send up to 512 DMX channels down one wire for one chain of devices to control all of their different parameters. And this would make one DMX universe. A DMX universe holds 512 DMX channels. Now, some devices may need more channels than others, and some may need less. It depends on what the device is and how many features it has. If it's a simple fog machine, it might need 4 channels. One to control the fog output and how much it's outputting, one to control a built-in red LED, another one for a green LED, and the final one for the blue LED. Some devices that are almost the same may even take more or less DMX channels. For example, these two moving headlights I have, the bigger one needs 14 channels, but the smaller one only needs 12 because there's less features in the smaller one. So you can put lots of different DMX items in one single chain. You can have fog machines, moving headlights, laser beam controllers. Anything that uses DMX can all be hooked up together in one chain as long as you're not going over the 512 channels. Pretty simple, right? And it sounds just like pixel data if you're familiar with those and have built a light show with them before. But here's the part where it gets a little bit tricky and isn't like pixels at all. Every single channel of data you're sending down a chain for DMX devices is going to go to every single one of those devices. So if I have 5 simple lights hooked up in a chain and each of them needs 5 channels, I'm going to have to send 25 channels total down that chain. But the problem is, each and every one of those devices is going to receive all 25 of those channels, and they won't know which ones are theirs. The reason this is different from pixels is because pixels know exactly which channels to read. The reason this happens is because when a pixel gets its data, it removes it from all the other data in the line and sends the rest to the next one. And then that one removes the data it needs, it takes it in, and sends it to the next one, and it continues on. DMX doesn't do this. All of the channels are sent to every single one of the devices. And this is why we need something called a DMX address for each device. A device's DMX address is used to tell itself this is the channel you need to start reading data from. Most devices normally have built-in screens or menus so you can go through and set the start address yourself. However, there are a few occasions where some rare devices may not allow this, and they'll be set to use specific channels. We don't have to worry about that though right now. But let's do a quick example right now to see how this DMX start address works. So here I have two of my moving heads set up, and let's say they're receiving data from this controller. Well, I want this one to be first in the chain, connected right to here, and then I'll have this moving head connect to this moving head. So it will go this one and then that one in the chain. Well, this moving head takes 14 channels, and since it's at the beginning of the chain, I could just leave it set to channel 1 because I want it to read the first channel of data. But as you can see, I can go to the menu and hit the address setting to change what the start address is, or the DMX address. So I could set it to, let's say, 8, and now this means it will start reading channel 8 and the next 14 channels after that, because it needs 14 channels of data. This number can go all the way up to 512, since you could fit 512 channels in a universe, but it wouldn't be able to read anything beyond 512, since that's the highest you can go. I'm going to leave it set, though, for 1, since it's the first one in the chain. Now this moving head, this is the second one in the chain, and since this one takes 14 channels, it's going to take all of the data between channels 1 and 14, meaning I'll want to start this one on the next open channel. That next channel is 15, since 15 isn't being used. So I'll go on here, hit menu, it's in the address, so let's hit enter to edit the address, and you can see it's set for 1. So I'll hit up until it reaches 15. And let's see, and there we go. Now it's set for channel 15, which means this moving head will start reading data at channel 15, and it will read the next 12 channels after that, since this only needs 12 channels. So this whole setup would use a total of 26 channels, the 14 from here and the 12 from here. We have the start address on this one set to 1, since there's nothing before it, so we could start reading it at 1, and it ends at channel 14. So we have this one and the DMX address on here set to 15, so we can read the first open channel after this. Now if we were to start a new chain and hook up a different chain to the controller, that would have its own universe for it. And the first fixture could start at 1 again, and then the next fixtures would have to start on the next open channel. But that's how you hook up anything DMX to each other, and that's how you set the DMX address. So that's the basics on what DMX is. Now I understand it's confusing and it might take you a little bit to understand it, but something that helps me out is drawing up my setup on a piece of paper or something. Drawing all the available channels that I need and like grouping them together for each fixture so I can tell which ones are going where. Let's move on to the next section though, where we'll talk about how to hook up DMX moving heads, how to get them working, and how to hook them to our controllers. So before we look at how to connect these to a controller, let's first look at what these need to function. Just like anything else in our Christmas or Halloween light displays or whatever displays you have set up, your items need power and a data signal. And these are no different. They each need power and they need a data signal to work. So we can look at the backs of both of these to see a little bit of a difference between them and how you connect your data and power to both of these moving headlights. So on the back of this smaller moving head first, you'll notice that we have our DMX in connector with our XLR connector, our DMX out, we have a fuse on this one, an on and off switch, and our power connector. And then if we move over to the bigger, more expensive moving headlight, we have a couple of different things here. We have our DMX in and out connectors right here, DMX in and DMX out with an XLR cable. We don't have an on and off switch or a fuse out here, but we have a power in and a power out, something that the other moving head doesn't have. It doesn't have a power out. So with this moving head, what you can do is chain the power off of them together. So I could have power come into this one and come out to another moving head. Now you might notice the power connectors look a little bit different on the two moving heads. And that's because these are using two different types of connectors. Both of these moving heads are using power con cables, but they're two different types of power cons. The smaller, cheaper moving head is using the older blue and gray power cons. The problem with these older ones is it's extremely unsafe to plug it in or unplug it when power is on. So if you have these older cables, make sure you unplug it, you disconnect power before plugging it in. If you don't, when you're rotating it to pull it out, it could cause it to arc inside and completely fry the moving head and even start a fire. So don't do that at all. The bigger, more expensive moving head is using the black, newer power cons. It works the same way where you rotate it, put it in, and twist it to lock it, but these are safe to take out if power is connected. Just so you can see the difference, this is what the two connectors look like. You can tell the newer one apart from the older one because of the little lines that it has connecting to the center, whereas the blue one, the older one, doesn't have that. You can also tell a little bit of a difference on the moving heads themselves. Here is the newer connector on the bigger moving head, and here is the older connector on the smaller moving head. To plug it in, you can see the little notches in the circle there, and the little bumps that stick up on the connector. You put those in slightly rotated, and then twist it, and it locks in. To unlock it, pull this back, twist it, and remove it. It's the same on here. We got to find the power in connector, which is this one. We can see the little bumps on the connector itself right here, and the little notches in the hole. And the newer connectors also have 4 notches total. So we put that in at a slight angle, rotate it, it locks in, and then to take it out, pull this back, rotate it, pull it out. Now to get the data to these things, they use XLR connectors, like I said, that plug into the back or somewhere on the device. And they'll either be 3-pin connectors, most of the time they are 3-pin connectors like these, and then you might have a few devices that have 5-pin connectors. Whether they're 5-pin or 3-pin, the pins will be ground, data positive, and data negative. The 5-pin connectors just have 2 data positives and 2 data negatives. Now a big mess up you might make is these connectors are the exact same used for microphone cables. And you might think you could just get microphone cables to connect DMX products together. But that is a big no-no because the impedance rating on them is a lot different. Microphone cables are for sending analog signals, whereas DMX cables are for digital signals. So you want to make sure that you are specifically buying DMX cables, because if you plug in microphone cables, you'll have a lot of problems. The signal won't work half the time, and I just don't recommend it. So make sure you get DMX connectors. And DMX connectors, they just simply plug right in, like that. And on the female side, there'll always be a little button or thing to pull on to unlock it. And since this is the female side on the moving head, this is the little button you push to unlock it here. So if I plug in this side of the cable, it is going to lock in. And the way to pull it out is push this button up here, and then I can pull the cable out. Now the next thing you might be wondering is, how do you get the data to these things? What controller do I need to get the data to go over the DMX cable to these things? Well, surprisingly, a lot of Pixel controllers and even a few AC controllers have DMX support built right into them. A lot of the popular Pixel controller brands like Falcon, Genius, Cult boards, a lot of them have built-in DMX outputs. Now, even if your controller doesn't have a DMX output, there are a lot of places that sell different controllers that you can easily connect to have a DMX output. These can easily connect to your show player or whatever the main device is running all of your controllers. So grab your controller, look on the board, see if it says if there's any DMX outputs on it, or look in your manual to see if it has that included. Now, all of the newer Falcon controllers coming out, anything F16 or F48, V3 or newer, they all have DMX built into them. For the older controllers, I'm not 100% sure, but you can't even buy them now anyway. The only problem is getting the DMX data out of these controllers. You'll notice there's not a spot to plug in this cable anywhere here on the board, so how do we do that? So here on the F16 V5, the DMX output is right here. It's this RJ45 jack. It looks like an Ethernet jack and it fits an Ethernet cable, but technically it's an RJ45 jack, and you say it like that because it doesn't take Ethernet signals like internet connections and stuff like that. And actually, almost every controller that has a DMX output will output it with an RJ45 jack, not the XLR cable jack that would make it most convenient. It's this. And the reason why it's this is because they commonly make it so you can run other things besides DMX from this jack. On the F16 V5, it's set up so you can run DMX from it, you can run LOR controllers from it, you can run Renard boards, a bunch of other stuff. Well, not really, actually that's all of it. But you get the point. They made it so it could do multiple different things. So we will need an adapter, but we'll get to that in a minute. First, we have to do something to make sure this is set for DMX mode. On a lot of Pixel controllers, there'll be some jumpers that have to be set to change the mode between LOR and DMX or whatever it's outputting. So you'll see here, these 3 jumpers are used to set the mode that this RJ45 jack should be in. If all 3 of them are to the right, you could see right there it says DMX. But if all 3 of them are set to the left, you could see it says LOR. So right now I have them all set to the right, meaning that it's going to work in DMX mode and that the pinout will be for DMX. But if I was to pick these jumpers, pull them off, and put them on the left, it would be set for LOR. So now you can hook just a standard Cat5 or better cable into that jack, and then the other end can go to the moving head or whatever DMX product you're using. But there's nowhere to plug this in, so how do we handle that? Well, you have 2 different options. First is you could buy some sort of adapter similar to this, where it will take that Cat5 cable and convert it to an XLR connector like this. So this could plug right into my DMX device, and then I could plug the cable in here. And normally the wiring is all correct, so it takes the correct pins from the Cat5 cable and puts them to the right pins for XLR. Or if you're the DIY type of person, you can make a custom cable, which isn't too difficult to do as long as you know a little bit of soldering. What you'll need to do is see which wires your controller is outputting the DMX signal on in the Ethernet cable. Because there's 8 different wires in an Ethernet cable, but for most of these adapters, there's only 3 pins. So if we look in the manual for the F16 V5, we'll see that when the jumpers are set to DMX, the white, orange, and solid orange wires are the data positive and data negative wires. And then both the brown wires are the ground wires. You can then look up a pinout for the XLR connectors, and we can see here which ones are the data positive, data negative, and ground wires. And we'll cut an end off an Ethernet cable and connect the correct wires to the correct pins. You can buy XLR connectors themselves that don't have wires on them, and then you can unscrew it to access the insides, pull all of this stuff off, and we could push this little black part piece in if it'll come out. You might need to take a screwdriver to push that out. And then we could see here, we have the connector right here, and then the pins on the back, the 3 pins right there. So we could solder on our wires right into that. And then when you're done, you can reassemble the XLR connector. So now I'm going to quickly hook these up to the controller, wire everything up, and that way we could go into xLights and look at how we add these to the layout and program them. And that's going to finish it up for the first part of this tutorial. Like I said at the beginning, I felt that there was too much to cram all in one video, so the rest of this video will be in the next video. But for right now, if you have any questions or comments with what we've talked about so far, please feel free to put them in the comment section down below, and I'll try to respond as soon as I can. If part 2 is already out, I'll link it up here so you can continue on with this tutorial, or take a break if you need to let your mind absorb all of that information, which is totally understandable. But other than that, thank you for watching, and I'll see you in the next video.